Hi friends, in this episode we can see about strong base anion. Strong base anion is required to remove anions like chlorides, sulfates, and nitrates. Nitrates is rarely present. Weak carbonic acid from degasser tower and silicic acid and phosphoric acid, which is also rarely present. All these coming out of the degasser tower will be removed in SBA resin. The SBA resin type is quaternary amine group. Resin form is ROH minus. Color is brown in color. The density of SBA resin is 1.1 to 1.15 gram per cc. Unreacted chlorides and sulfates from weak base anion, and the remaining carbon dioxide from degasser tower, and weak silicic acid and weak phosphoric acid are removed in SBA unit. The SBA outlet water is called demineralized water. This dim water quality you can see now. If sulfuric acid is used in strong acid cation, then the pH will be slightly higher. Normally should be 7.5 to 8.5, but it will be on the higher side. And the conductivity will be less than 10 microsiemens per centimeter or micromoles per centimeter. If HAL is used for regeneration in SAC, then we can get very low conductivity. It will be less than 2 microsiemens per centimeter. Total knowledge will be nil for both type of acids. Chlorate also nil. Phenolphthalein alkalinity or P alkalinity will be 5 ppm if H2SO4 is used, and it will be almost nil if HCl is used. M alkalinity, methyl alkalinity also will be 5 ppm if H2SO4 is used, and it will be nil if hydrochloric acid is used. Turbidity will be nil for both the regeneration. Silica normally 0.2 ppm if H2SO4 is used. If we use HCl, then it will be less than 0.02 ppm. This is because of the effective regeneration in the SAC. We can now see the strong base anion service reaction. The resin form is ROH. The weak hydrochloric acid, weak sulfuric acid, weak carbonic acid, weak silicic acid, and weak phosphoric acid coming out of degasser tower will get reacted with the resin ROH to form RCl. That is, resin will absorb the chlorides, sulfate, carbonate, silicate, and phosphate, and water will come as DM water. These chlorates, sulfates, and carbonates, and silicates, and phosphates will replace the OH ions. That OH ion will join with this hydrogen ion of this weak acid to form DM water. If the silica content is more than 0.2 ppm or SBA yield crosses the value, then SBA and WBA are taken for regeneration. They are regenerated together by the method called Thoroughfare method. Regenerant coming out of SBA is injected to WBA top. Normally 5% NaOH we are using for SBA, and WBA it will be diluted and 2% NaOH is injected. The SBA and WBA regeneration equation we will see now. In the SBA 5% NaOH is used, that will replace the chlorate, sulfates, carbonates, silicates, and phosphates in the resin. To react with this and the resin back to ROH form. Sodium chloride, sodium sulfate, carbonate, sodium silicate, and sodium phosphate will come to drain. And the outlet of NaOH, SBA NaOH is 2% coming to WBA, and it will regenerate the WBA resin. Normally it will be in the form RNS3Cl and RNS3SO4. So which will react with this 2% NaOH, and the resin form is normalized RNS3OH. Sodium chloride and sodium sulfate will go to the drain. This is the schematic diagram of SBA and WBA regeneration by Thoroughfare method. SBA is injected with 5% NaOH, and the outlet is diluted with pure water, and it will be injected as 2% NaOH in WBA. Both the beds are taken for regeneration together. This is the SBA bed filled with SBA resin, quaternary ammonium compound. This is tertiary ammonium compound. This is the degasser tower outlet coming through the pump. This is the backwash inlet line, and this is the air vent line, and this is the backwash outlet line, and this is the regeneration outlet line, and this is the vinyl rinse outlet, and this is the SBA outlet line going to the DM storage. And if a mixer bed unit is there, and this one line is branches to mixer bed unit. The regeneration outlet of SBA will be diluted with the power water for WBA, and it will dilute the NaOH concentration to 2%, and that will be injected to the WBA. This is the SAC outlet coming to WBA. This is the air vent line, this is the backwash outlet line, and this is a backwash inlet line, and this is a drain regenerant outlet, and this is the WBA outlet for service is going to degasser tower. Now we will see how the regeneration is take place. Normally, if the SBA bed is exhausted, that is if 0.2 ppm silica is attained, or it is more than 0.2 ppm, or if the yield crosses for SBA, both are taken for regeneration. Normally, WBA will not get exhausted just before SBA, or both will be taken simultaneously, so the yield will cross simultaneously. So both units will be isolated, and backwash will be given, and the NaOH taken for SBA regeneration will be more, because after regenerating the SBA resin, the excess quantity will be injected for some time. That only will get diluted with the pore water, and that is injected to the WBA as 2% NaOH. Both the units are taken together by the method Thoroughfare method. So it will minimize the NaOH concentration or NaOH consumption if both are regenerated separately. That's why a little higher volume of SBA regenerant is enough to get diluted for injection of WBA. So after the backwash, both units are kept ready, and 5% NaOH injected to top of the SBA, and the outlet is coming. Initially, all the resin will get exchanged, so the outlet water will not contain any NaOH. Even though the power water is coming, only the regenerant coming out of the SBA outlet will go to the drain. When SBA injection is completed, that means that all the resin got exchanged, then we will get slowly slipping of NaOH. That is, the NaOH concentration will get increased from 1% to 2% until it will come to 5%. And the pore water we set as per the design, it will dilute the sodium hydroxide coming out of the SBA, which will normally 5% after some time. After regenerating the SBA bed completely, it will get diluted to 2% NaOH, and that will go to the injection header to WBA, and it will regenerate WBA. Initially, WBA will not get regenerated. After some time, when the NaOH started coming, then only WBA will get regenerated, and that WBA outlet regenerant is coming out this. After the injection is completed, then both will be given final rinse through this line, and this is taken out final rinse outlet, and for this WBA it is regeneration outlet. As usual, here we will check chlorides for the regeneration completion. Here we will check silica value for regeneration completion. So this in this Thoroughfare method, both the SBA and WBA are regenerated with sodium hydroxide with a minimum quantity of NaOH taken in the light dilution tank, and it is effectively regenerated. Now we can see some important questions asked and the answers for DM plant. Why SAC is situated first, then SBA? Why not SBA is situated first? You can see the answer now. SBA resin exchange will take place in acidic range. It is very effective in acidic pH only, that is between 3.5 to 4. if SAC outlet is directly going to degaser tower in the absence of WBA. Then the SAC goes to degaser tower where carbon dioxide is getting removed and it will go to SBA. Then the pH will be 3.24. At that pH, low pH, SBA exchange will be effective. The second reason is if it is going to WBA and then to degaser tower, the pH will be slightly higher. Then also it is in acidic range 4.5 to 5.5 it will be. It goes from WBA to degaser tower, only chlorides and sulfates getting removed in WBA, CO2 in degaser tower. The remaining load all will get treated in SBA at in acidic range. If weak carbonic acid can be easily removed by means of low pressure air, it is happening in degaser tower. So we can remove the carbon dioxide from 100 ppm, which will normally present due to the bicarbonates of calcium, magnesium and sodium, and that can be reduced to less than 10 ppm. No need for any resin or no need for any regenerant. So with a mild pressure air from a blower air, we can remove the carbon dioxide. This will reduce the SBA load. So SBA is situated after the degaser tower, after the SAC. And the main reason is if SBA is situated first, hydroxide will be formed, sodium hydroxide, calcium and magnesium hydroxide, because the chlorates, sulfates and silicates and phosphates will get absorbed in the bed, and the OH ion will join with sodium, calcium and magnesium, and that will get coated over the resin bed as NaOH, CaOH twice, MgOH twice. That will stop further reaction. So the hydroxide coating will be formed over the resin bed that will clog the resin pores and further reaction will not take place. So SAC is situated first, followed by WBA and degaser tower, then only SBA. So SAC will come first, then only SBA. The next question is why sodium slip in SAC and silica slip in SBA is occurring. Sodium is a monovalent, and sodium being monovalent it will slip first. Also, if it has got less affinity to the SAC resin, so sodium ion will slip first. It can be avoided by selecting regeneration type by countercurrent regeneration and HCl as regenerant instead of H2SO4 before erection. Before selecting the plant or before erecting the plant, we have to select the method possible based on the load in the raw water. So if you don't need any problem in boiler due to sodium slip which will cause castic embrittlement, we have to go for countercurrent regeneration, and the arrangement should be made as countercurrent regeneration. Also we can use HCl over H2SO4. This HCl will avoid sodium slippage, as well as the purity of DM water will be very high compared to HSO4 regeneration. So sodium slip will be avoided if HCl is used and countercurrent regeneration is followed. Similarly, if silica will slip first, because silica has less affinity to the SBA resin than other anions like fluorides, sulfates, and carbonates. It can be avoided by maintaining the correct usage percentage of regenerant NaOH 5%, which is used for the NaOH SBA regeneration, and with extended backwash after some for 3 or 4 regeneration. After 4 regeneration, we have to give extended backwash and little more higher quantity of regenerant we can use, so that we can have effective regeneration for the SBA. This will lead to avoid sodium silica slip from SBA. The next important question is what is fouling and which will foul in strong acid cation and SBA resin. Fouling is blocking of resin pores by insoluble materials or insoluble solids, which will stop further reaction or further exchange in the resin bed. This will be followed by the reduction in the yield, that will reduce the yield, and the pores are blocked because of the fouling, that will break the resin. So resin volume also will get reduced, Further, it will reduce the yield of the bed. HAC is normally folded by ion. Ion folding will occur in strong acid cation, and organic folding will occur in SBA. Ion folding and organic folding in DM plant. Ion folding will occur in strong acid cation, but even very small quantity of ion present in raw water, it is 0.2 milligram per liter or 0.2 ppm of ferrous from raw water. When it get oxidized to ferric, which is insoluble, and that will clog the resin pores. That will fold the HAC resin. So due to this, folding occur in HAC. Also, corrosion of equipments will lead to iron folding in HAC resin. If the HAC bed is regenerated with H2SO4, it tends to have iron folding. Iron folding will reduce exchange capacity or exchange rate in HAC resin. Iron folding can be removed with citric acid or HCl. We have to soak HAC resin bed with HCl 10% for 12 hours to 24 hours based on the recommendation by the vendors. And then we have to regenerate with double the quantity of regenerant, that is H2SO4 we used. If HCl is used normally for the regeneration, then iron folding will not occur. So if SAC is having any problem with iron folding, when H2SO4 is used, then we have to remove the iron folding by means of 10% HCl followed by double regeneration. If organic matter present in raw water, that will react with strong acid cation resin to form organic acid, which will fold the SBA resin. This organic matter present in the raw water will fold the SBA resin. This organic folding you can find out during the final rinse of the regeneration. During the SBA at final rinse, the rinse outlet water will be brownish in color or like wine color. Organic matters or organic impurities which may present in raw water, which normally getting removed in pressure sand filter and activated carbon filter. If activated carbon filter got exhausted or it failed to remove the organic impurities, and the schematic, that is skin, which we have seen in the previous episodes, which forms thin layer or pressure sand filter top layer or activated carbon filter. Also, it will form in any TM plant units, and the schematic got disturbed due to wrong operation. Organic slippage will be there. That is, if you increase the pressure sand filter or activated carbon filter backwash flow more than 1.5 times the service flow, normally the schematic will be disturbed. It will occur in both PSF and ACF. Immediately after the commissioning, you will have the dirty skin or schematic in pressure sand filter and activated carbon filter. If your operation is very effective and you are maintaining proper backwash flow and proper air scoring followed by backwash correct flow, then your schematic in PSF will not get disturbed. So if it is disturbed, you will get microorganism slippage and organic matter which is balanced by the schematic also will slip, and that will come to ACF. And if the ACF is exhausted or ACF is giving some slippage due to overload, then organic slippage will be there. Organic slippage can be avoided by routine replacement of activated carbon once in a year or once in 2 years, or proper regeneration of activated carbon during the shutdown if the activated carbon is of regenerative type. Can be regenerated with NaOH and steam around 800 degrees centigrade, normally regenerated. If the stomach deck is not disturbed in PSF or ACF, that also will help to avoid organic impurities to slip from PSF and ACF. Which we have seen about schematic in the previous episodes. It plays a vital role in any unit in TM plant, whether it is PSF or ACF or SAC or WBA or SBA. When you open the top manway of the bed, you can see the brown color sticky material over the topmost bed layer or in the side of the inside of the wall. So you can see the brown color sticky material which is called stomach duct due to the sulfur reducing bacteria join with iron and manganese and slime to form this thin layer. That not only prevent the microorganism to pass through the bed, it will kill the microorganism, and also it will not it will disturb the organic matter to not to get pass through the ACF. So organic matter also will get removed in the PSF. So if the schematic deck is maintained properly, you will not get organic matter. And if there is any slippage, then it will be taken care by activated carbon filter, which will remove free chlorine, also organic matter. Organic fouling from SBA can be removed by alkali brine treatment. If you see the final rinse outlet reddish wine color or reddish brown color, then the unit is having organic fouling. Then you have to give the bed alkali brine treatment. 10% sodium chloride with 2% NaOH is injected into the bed so that bed will get completely exhausted. Then the bed is to be doubly regenerated with the 5% NaOH. That means that organic fouling can be can be removed by means of the alkali brine treatment followed by double regeneration. Hope you might understand the SBA WBA Thoroughfare method, SBA service reactions, SBA WBA regeneration reaction, and some important questions asked in DM plant regarding SAC, WBA, and SBA. Do not forget to subscribe or do not forget to share these videos to your friends and colleagues. Please put your likes. Thank you very much. See you in the next episode with more information about mixed bed and other DM units.